so far. Okay, so some review activities we got here. So first thing is we are going to go ahead and graph this exponential function. F of x is equal to 1/3 to the x. So I'm guessing that you're going to make a table. That's what I would definitely do because we haven't encountered this one yet. So because it's a fraction in there and I want to have as many whole numbers as possible, I'm going to put in some negative exponents into this. And then since it's a small fraction, I'm just going to put in a 1. You can put in other values, but these are going to be probably the ones that produce the useful values for me. So remember, when I put in a negative exponent, I have 1/3 to the -2. Negative exponents flip my fraction. They flip my base. So this becomes, instead of 1/3, it's going to be 3 to the 2nd power. So 3 to the 2nd power is 9. When I put a -1 in, 1/3 to the -1, well, again, the negative exponent flips that base. So instead of 1/3, it becomes 3 to the 1st, and that's 3. 1/3 to the 0 power, we've come to expect that anything I raise to the 0 power is going to be 1. And then 1/3 to the 1st power, well, anything to the 1st power is just itself. So that's 1/3. So there's my values that I'm going to use to get the shape of this exponential. So here goes, -2 goes up to 9, -1 goes up to 3, 0 is 1, and then over 1 up 1/3. So here is my graph. Remember, I told you this, when I grade your graph on the test, I'm going to just look for a couple things. I'm going to look at your points, make sure you've done your multiplication right, of course. But then the other two things I'm going to look for is, are you obeying the horizontal asymptote? Okay, this basic graph is not going to go through the x-axis. And then I don't want you to accidentally make a J out of this. So just, it's going to get closer and closer. I'm going to stop there because I don't want to go through. I also don't want to accidentally start coming back up because it's not going to start coming back up. Okay, but that's sometimes students' inclination is you get scared when you get by the x-axis and then you start drawing the graph up again, and that's wrong. There's no need to do that. So there's my graph. The domain and the range, this should be pretty familiar. It's the same thing we've seen a bunch of times. The domain of my exponential is -infinity to infinity. It's going left to right forever. The range, since it doesn't go through the x-axis, the range is 0 to infinity with a parenthesis around the 0 because it's not going to be equal to. How am I going to answer the next question? Is this one increasing or decreasing? Yeah, it's clearly decreasing. That could have been something you answered before graphing it. If you remembered that anytime my base is bigger than 0 or less than 1, you're going to get a decreasing graph. If the base is bigger than 1, okay, I'll just write this down. Again, this is just review. If the base is bigger than 1, then that produces an increasing graph. And then lastly, what is the visual test to determine if a function is 1-to-1? Perfect. So here's my horizontal line. Somebody left a Polk State card. Notice this horizontal line hits the graph in one point everywhere. So this would be 1-to-1. So yes. And I'm just going to put HLT, horizontal line test. So there are the basic questions for that. Then I asked you to do 2 fairly quick problems of what we did today. Again, I know today was tough stuff. So first, solving this is just using the definition. So according to the definition, what's the base of this logarithmic statement right here? 4. What's the exponent? And then equals 32. If you got that, then that's today's new material. You've done fantastic. Solving this is what we talked about last time when we introduced the exponential. I'm going to use base 2 here. So 4 is 2 to the 2nd. 32 is 2 to the 5th. 2 to the 2nd raised to the x power is 2 to the 2x power. And then because the exponential is a 1-to-1 function, I can say these two things are the same if the exponents are the same. And when I divide by 2, that produces a value of 5/2. So there's my solution to this problem, 5/2. The last problem for the day was go ahead and write this as a single logarithm using those properties of exponents. So the first thing I'm going to do is I'm going to use the power rule since I've got those coefficients. So I'm going to bring this 5 and I'm going to bring this 3 up and make them powers. So I've got log base a of x to the 5th minus log base A of y to the third, and then minus, I've got a 1 in front of this one, so I'm just going to leave it like that. And then like I did last time, I'm just going to go one pair at a time. So I'm going to look at these first two right here. I've got a minus sign between them. I subtract my exponents when I divide. Okay, so I'm just using, these are very similar to the properties of exponents. I subtract my exponents when I divide. So I have the log base A of x to the fifth divided by y to the third. I have another minus sign. That means I'm dividing again, which means that my next thing is also going to go in the denominator. So here is the final result. I've got the log base A. I've got the x to the fifth in the top. I've got the y to the third in the bottom. And since I have this minus sign here, I'm going to put this z also in the bottom. I'm dividing. And there was just a couple quick problems to review today.